SWL Remediation, Topic 12, Logic. Venn diagrams. Venn diagrams describe sets or lists of things. Some rectangles are rhombuses. Rectangles would be the circle on the left, and rhombi would be the circle on the right. Some, because they overlap. Some or both. None. No rectangles are circles. Rectangles on the left and circles on the right. There are no rectangles that are also circles, so they do not overlap. All squares are rectangles, or some rectangles are squares, but not all rectangles are squares. If rectangles were the outside and squares were the inside, I can see that every single square is a rectangle, but there are some rectangles that are not squares. We'll see that in our next example as well. Examples. All dogs are animals. All dogs are animals. That's going to be this circle contained entirely inside of the animals. And some animals are dogs. The animals that are dogs also fits inside of this circle. Some animals are dogs. But not all animals are dogs. Every other animal would not be a dog. That would be contained in this part of our picture. Statements. Conditional, an original statement. If P, then Q. It's written P arrow Q. That arrow means if then. If P, then Q. This means that all P are Q, or that some Q are P. Inverse, opposite. If not P, then not Q. Right? We'll use the symbol for not in front of the P. That tilde sign means not. If not P, then not Q. Converse, a flip. If Q, then P. We'll write this as Q arrow P. If Q, then P. We have flipped our statements. Contrapositive. This will be the opposite and flip. If not Q, so it's both the opposite and flipped, then not P. And we'll write that with the tilde sign again. Tilde Q, then tilde P. If Q, then, if not Q, then not P. And lastly, we have our biconditional, which goes both ways. P, if and only if Q. P, an arrow pointing both directions, Q. This means that all P are Q and all Q are P. P if and only if Q. Statements continued. And. P and Q. That means if the left is P and the right is Q, P and Q would be the center. P and Q. We have that caret pointing upwards. Or P or Q. Again, on the left we'll have P, and on the right we'll have Q. P or Q means anything in either bubble would be P or Q. It could be just P, it could be just Q, or it could be both. P or Q. This time, we have that caret facing downward. Laws of logic. Detachment. P, then Q. If P, then Q. P. This means that P is true. Therefore, Q. Therefore, Q is true. We've detached the two. Syllogism. P arrow Q. If P, then Q. Syllogism Think of a domino effect. So if P, then Q must happen. If Q happens, then R must happen. If Q, then R. Therefore, if P happens, then R must happen. Therefore, if P, then R. Also syllogism. If P, then Q. If Q, then R. P is true, therefore R is true. Contrapositive is true when the conditional is true. Converse is true when the inverse is true. Pay special attention to that contrapositive fact. We'll be using that shortly. Laws of logic. Contrapositive is true when the conditional is true. Detachment using contrapositive. If P, then Q. If P, then Q. Not Q. Q is not true. Therefore, not P. Therefore, P is not true. Syllogism using contrapositive. If P, then Q. If Q, then R. Therefore, if not R, then not P. Examples. Which Venn diagram represents all of the following statements? Statement 1. Some triangles are acute. Some triangles are obtuse. No triangle is both acute and obtuse. That means that if there's an overlap between acute and obtuse, it must not reflect this statement. No triangle is both means they cannot overlap. And here again, we see that the acute and obtuse overlap, which cannot happen. Some acute triangles are equilateral. Some acute triangles are equilateral. That means that the two must be able to overlap. See how some of the acute triangles are equilateral? That means this is our solution. Below it in J, the acute and the equilateral do not overlap. In J, some of the acute triangles are not equilateral. That's why it cannot be our solution. Consider the following statement. If 4 times x equals 8, then x equals 2. Which is the inverse of the statement? If x equals 2, then 4x is not congruent to 8. If x is not equal to 2, then 4x is not equal to 8. H, if x equals 2, then 4x equals 8. Or J, if 4x is not equal to 8, then x is not equal to 2. Our P in our given statement is 4x equals 8. Then our Q is x equals 2. To write our inverse, we know that it's going to be not P, then not Q. So we'll take our P and make it not P. And we'll take our Q and make it not Q. 4x equals 8 becomes 4x does not equal 8. X equals 2 becomes x does not equal 2. So in our if statements, we'll look for our not P, and in our then statements, we'll look for our not Q. So not P, 4x cannot equal 8, is right here. And our not Q, x cannot equal 2, lines up perfectly. Therefore, my answer is J. Using deductive reasoning, if the first two statements are true, then which third statement is invalid? We need to focus on that term, invalid. That means not true. Let's look at our laws. First, we have syllogism. If P, then Q. If Q, then V. Therefore, if P, then V. I see that C matches this almost exactly, so it is valid. Let's look a little deeper. I see that A is really close, but at the very end they switch it up. So let's try our contrapositive. If P, then Q. If Q, then V. And using our contrapositive, we know if P, then V is true. Therefore, not V, then not P must be true. That makes this option, A, valid as well. And that's just not going to match up. So let's look at our syllogism one more time. If not P, then not Q. If not Q, then not V. Therefore, if not P, then not V. Option D follows our law of syllogism perfectly, so it is valid. So by the process of elimination, I see that my answer must be B.